Hello, this is Mr. Stansbury. I'm going to take you through the notes on the discriminant. At the end of this, you should be able to say, I can use the discriminant to determine the nature of solutions. Okay, so first thing, the discriminant. If you remember, the discriminant is b squared minus 4ac. Okay, so if you go through and find the b squared minus 4ac is greater than 0, then that means you get two real solutions and two x-intercepts. It's going to look something like this. Okay? If this b squared minus 4ac, if it's a perfect square, like remember perfect squares are like 4, 9, 16, 25, so forth and so on. If it's a perfect square, then the roots are what we call rational, right? Because you're just going to have actual, just whole numbers there. If the root is not a perfect square, then the roots are irrational. Okay, so that means it's going to have some kind of root in there. So if you see that there's some kind of, you end up with a square root in your answer, that means they're irrational. If there's no square root, then it's rational. If b squared minus 4ac happens to equal 0 and only 0, then there's just one real rational solution. We call that a double root. And there's just one x-intercept, so it only just touches the x-axis in one spot there. Okay, so like there's your one x-intercept, there's your two x-intercepts up here. Now, if b squared minus 4ac is less than 0, then that means it doesn't actually even cross through the x-axis at all. So there's two complex solutions. There's no x-intercepts. Okay, let's not worry about this conjugate business, but two complex solutions, and there's no x-intercepts. Okay, so using that info there, let's take a look at an example. Okay, so for each equation, find the value of the discriminant and describe the nature of solutions, and then find the x-intercepts. Okay, all right, so on this one here, we've got everything's in quadratic form. So we're all good. So we want to just make sure, remember to use the b squared minus 4ac. That's our discriminant, right? Okay, so in this case here, we've got b, which is negative 2 squared minus 4 times a is 1 times c is negative 15. So negative 2 squared is 4. Negative times a positive times a negative is a positive. 4 times 1 is 4 times 15 is what, 60? So we get 64 is our discriminant. Okay? Now, it is fitting in up here. It's greater than 0. It's equal to 0, less than 0, or greater than 0. This one's greater than 0. And it is actually a perfect square because 64, the square root of 64 is 8. Or 8 squared is 64. So that means we have two real solutions, and they are rational. Okay, and so then if we are, let's see, that's really the big thing that we need there. So describe the nature of solutions, and then find the x-intercepts. Okay, so we want to actually go through and find what those are. So to find the x-intercepts, let's do this in a different color. So to find the x-intercepts, you can try to factor it, or you can plug it into the quadratic. Okay, because since this ends up being a perfect square, the roots are rational, then this should be able to be factored. Okay, if they're irrational, then they're not going to factor. So if they're irrational, then you'd have to plug it into the quadratic equation, okay? Which you can find in your notes and other spots here, but I'll put it up there really quick. So we got x equals negative b plus or minus square root b squared minus 4ac all over 2a. That's if this is not a perfect square. But since this one is, then we can simply just factor this thing. How about this? Let's pretend we didn't know that it was factorable. Let's just plug it into the quadratic, because we can plug all these into the quadratic and it'll always work. So let's do that. x equals negative b, which is negative 2. All right, minus 4 times a, which is 1, times c, which is negative 15. Wait, back up. I was, sorry, I was not paying close attention here. Negative 2 plus or minus square root. B is negative 2 squared minus 4 times A is 1 times C is negative 15. All over 2 times A, which is 1. Okay. So we already figured out that that in there is 64. So we got 2 plus or minus a square root of 64 over 2. So in this case, we got 2 plus or minus 8 over 2. And really we could do 2 plus 8 divided by 2 and 2 minus 8 divided by 2, or we can simplify them whichever way you want to do it. Let's just do 2 plus 8 over 2 and 2 minus 8 over 2. 2 plus 8 is 10 divided by 2 is 5. And then 2 minus 8 is negative 6 over 2 is negative 3. So those are the X-Intercepts. 5 and negative 3. Okay? Okay, let's do this one last one. But before we do that, let's take a quick little comedy break.
Hey, here's something I don't think a parent has ever said. The kids are upstairs playing with all their old Happy Meal toys. I don't think a McDonald's Happy Meal toy has ever made it to sundown. Usually they break as you're taking them out of the cellophane. What is this? Oh, it's broken. Toss it into the trash receptacle. Even if you do get it to work, you never want to do it more than once. That's what happens. You push this button, it shoots at 4 inches. Throw it in the trash. Somebody shut that toy factory down.
Okay, let's take a look here at the last one. 4x squared plus 4x plus 1. Let's see. So we're going to find the value of the discriminant, right? So we get, it's going to be b squared minus 4ac. So we've got b is 4 squared minus 4 times a, which is 4, times c, which is 1. So 4 squared is 16. Negative times a positive is a negative. 4 times 4 is 16 times 1 is 16. We get 0 for our discriminant. That is going to be this case right here, right? So we are going to get a solution that just touches the graph, right? Like so. Okay, so the nature of our solution is one real rational solution. Okay, and then it says find the X-Intercept. So in this case, we know it's just going to be one X-Intercept. So again, you can try to factor this. This one will factor. As long as it doesn't have a root in it, it will factor. But we don't know what those are going to be. So this is actually a perfect square as well, because square root of 0 is 0. But let's just pretend we'll plug it into the quadratic, because that will always work regardless of what number we get for our discriminant. Okay, so we get x equals negative 4 plus or minus 4 squared minus 4 times a, which is 4, times c, which is 1, all over 2 times a, which is 4. So really we don't even have to do this part, because we already know that that's 0, just like what we did up here. So we get x equals negative 4 plus or minus 0, right? Because the square root of 0 is 0. All over 2 times 4 is 8. So that just goes away. We have negative 4 over 8, which is just negative 1/2. There's our X-Intercept. X-Intercept is negative 1/2. Okay? All right, that's all we have for the discriminant. If you have any further questions, please feel free to ask. Thanks.